In this session, I'm going to talk very briefly about the SDI product team and our mission. I'm going to discuss at a high level the improvements that we have been making to the product in the last year. And then for the second half of the presentation, I'm going to dive headfirst into a demonstration of bringing a real product into VS and show you some of the features and workflows that you can use in your products and projects to be more productive and efficient while inside Visual Studio. And a little callback to last year, just don't forget that when you combine traditional Synergy and Visual Studio, we are unstoppable. So, first up, Synergy DBL integration for Visual Studio, or SDI for short, as you'll hear all of us refer to it. The SDI team is a small, fast-moving team at Synergex. We realized that in order to keep up with the release cadence of the technology that we work with, and in order to deliver customer features while they're still relevant, we need to be able to develop and release at a pace much faster than the runtime and compiler tool releases that many of you are familiar with, like in SDE. It's not only our editor integration that must be flexible, we have to be able to deploy compiler features, fixes, and performance improvements at the same rate. That's why all of the SDI builds that you receive are bundled with a complete set of the prototyping, compiler, linker, librarian, and all of the other tools that our build system relies upon. You still have to have SDE installed for all of the supporting libraries, utilities, and the runtime, but we can bug fix SDI regularly without breaking runtime compatibility. As Roger touched upon, our full unit and UI test suite can QA and fully test the product in 48 hours to the level of quality that you guys expect. That means that the developer build updates that we release are fully QA'd and supported for production code. That's right. Fully QA'd, fully supported for production code. And new regression tests are being produced from all of the issues that you guys find to drive the product quality forward every day. The tests don't have 100% coverage of the product. It is likely and possible for us to introduce bugs in these developer updates, but our turnaround time is much faster, and you don't have to worry about it. We can get you don't have to worry about wasting valuable developer time, is the point. In the event of a blocking bug, report it to support and roll back to your previous build. We'll work with support and get you an updated build as soon as possible so you can keep moving forward. And since you pick your runtime compatibility target, you don't have to worry about the developer tools introducing runtime problems. So, our mission. It's pretty straightforward. My team's mission is simple. Deliver a unified, best-in-class Synergy development experience in one IDE. And in order to do that, we definitely need your feedback. We want you to be able to work in Visual Studio at all times when working in Synergy code, including writing, building, and debugging. There's still a few feature gaps from Workbench, but we're planning to fill them. And for the most part, we need your feedback to know which areas impact you the most. If you have something blocking you in Visual Studio, we encourage you to reach out to us through email, answers, ideas, or support, and make sure your issues are on our radar. We're very active in the community site as well, and we're slowly moving a number of our own internal backlog features out to ideas so you guys can give us direct feedback. So, product improvements. Let's dig into them. I wanted to share some of the statistics first about what my team has been up to since the last conference so you can get an idea of what we've been doing and where we're going. In the bug fix category, we logged 170 new issues and subsequently closed them in this last year. Out of that group, 55 of those bugs originated through customers through support or answers. And this only covers issues that are logged into our system that could be encountered or seen by customers in the field. As I said in the last presentation, we use VSTS for internal tracking, so anything our QA team finds that's not in a build that's released to customers gets logged and doesn't get counted in this number. And then for new features, we tracked and completed 28 new features since the last conference. 17 out of that were direct customer requests, and 7 of those requests originated from ideas. We are looking to make this even more in the favor of ideas in this coming year, but this is how far we got so far. So some of those features include big ticket or time-consuming items, like adding support for Visual Studio 2017, redesigning our installers with the Wix toolset, bringing the visual debugger for traditional Synergy up to a releasable quality and usability level, and not to mention universal Windows platform support. So when I say that we added 27 new features, these things are included in that list. And these also don't include any of the items that were ultimately assigned to the compiler team or to the team responsible for the traditional debugger, for which our team does a lot of the initial testing. Since many of you are now interfacing with the products through Visual Studio, our logging and debugging tends to be what produces the very concise samples and bug reports that the other teams are using in development. So, performance improvements. Some of the important improvements that we made are specifically performance related and not only editor. Before we dig into what changed on the performance front, let's talk a little bit about how the ecosystem and all of you guys impact our ability to make performance improvements. One of the awesome things about having more customers work, develop, and build in Visual Studio is that we get to have a very well-defined and controlled DBL Proto, DBL, DB-Link process. Until now, most of you have had wholly custom build processes that utilize Synergy utilities in a variety of ways. While you'll notice some patterns and slowdowns in the tooling from time to time, there's a good chance that your use case may never get on our radar and fall through the cracks, and that makes it hard for it to get fixed. Then you get stuck with a slow build, and you may never even know why. So many of you have probably run into past limitations in the tools and worked around them in some way, right? Yeah? If you are prototyping your traditional code right now, you probably had to do something custom just to get that tool working right. And we wanted to solve that. We wanted to make it straightforward and simple. So many of those limitations that you encountered might have disappeared years ago, or even a decade ago in some cases, and your build system could be suffering for no reason, just because you haven't gone back and revised it. So what we're looking to do is have you build with our MS Build-based toolchain from a Visual Studio project to take all the guesswork out of the build process. When more customers are using our build toolchain that enforces our internal best practices, we can pinpoint performance bottlenecks and increase demand for new features that makes the builds smarter and faster. One example recently is we were able to coerce the traditional compiler to produce a listing of all the source in the compilation unit, including .includes, so that we in our build system could accurately identify all of the knock-on dependencies for your build. So we can then take those dependencies into account when deciding if a rebuild is necessary inside Visual Studio or at the command line with MS Build. So we then were able to get the compiler team to port this effort to the .NET compiler and introduce that same behavior for the .NET builds that many of you are already doing. So quality across the board. Having more of you in VS also helps us drive the quality and features in other Synergy utilities as we become the de facto interface for those features. Thanks to early adopters, we've been able to drive a large volume of fixes in the traditional debugger that continue to benefit everyone regardless of Visual Studio. Although, I think after you see Jeff's demonstration tomorrow, you'll probably want to spend all of your time debugging in the visual debugger. Performance improvements. So let's actually dig into the meat of these. The top one there, up to 80% improvement in prototyping speed. Our MS Build-based build showed that prototyping was taking much longer than expected when compared to compile operations on the same source base. The compiler team was able to improve prototyping speed up to 80% in some cases, which is a huge win for both builds and our IntelliSense background builds that provide you with the code completion that you see in Visual Studio. We were able to reduce the file size overhead on debug, DBO, and ELB files up to 50% in extreme cases. Some customer projects were demonstrating a massive file inflation in DBO and ELB files that was not in line with our expectations. So we were able to prove an erroneous overhead in those files and bring that size down in a meaningful way. We were able to do some optimizations for the VS build logic to shave an extra few seconds off build start. We eliminated a little bit of cruft in our own code base that was spending time doing something that you, when you're building, don't care about. So we were able to kick that off of the UI thread and reduce the work to speed up the start time on builds. There were significant improvements across the product, moving operations off the UI thread in general. So thanks to an increase in hands-on sessions with customers in the last year, we've been able to observe areas of the editor that are negatively impacted by background operations. So we moved several things off the UI thread and out of your way. I know there's still more room for improvement, so if you are seeing slowdowns in using the editor, send us an email and let us know. Solution Explorer search. So we can now provide results without requiring all the background IntelliSense operations to complete, which was the case before. So if you ever tried to go into the Solution Explorer, type in your search keyword, and hit enter, if there were still background builds running, you wouldn't see results until they were all done. And if you have a project like CU and you've got 60 projects open, that can take a while. So we finally found the right answer to decouple our Solution Explorer search and symbol information functionality from the background IntelliSense builds. So you should see much faster results and even always get file name matches if IntelliSense isn't ready. The trade-off, though, is that we can't update the search results after we hand them down to you. So if the variable class or method or symbol that you're looking for isn't in the search results yet, just hit the X button and search again. It should show up as soon as the IntelliSense is done. We're also able to shave some time off of find all references. It's been under a lot of scrutiny in how long our operations take. We solved a number of the worst cases that we could find, and we're looking to update the format of the results, as you heard in the updates, and also try to make it faster as possible. And then we were able to optimize how we handle the intermediate ELB and OLB files that we generate during the traditional build process. So for those of you that have already made the jump into Visual Studio with your traditional projects, we're making much smarter decisions with how many copies of those libraries that we move around. So between the OS level hard linking and we did some extra file cleanup, it's a night and day difference if you have a large project. So one customer that we tested against that's in this room has thousands of solutions and many projects that were resulting in well over 100 gigs of ELB files being left around on disk. So I don't actually know the exact number because when I tried to reproduce this, I ran out of disk space. When it was finished, when we finished this optimization, that solution produces only 10.4 gigs of libraries total. So it is far more manageable. And on to the live demo. So let me make sure I've got this set up right.
So for the live demo, I'm going to bring one of our internal traditional applications into Visual Studio from start to finish. The application is called Tracker. Some of you may recognize the name from how we refer to issues and bug tracking emails and conversation. It's written entirely in traditional Synergy and Toolkit, so it should be a pretty good example code base. So Tracker, the application was originally a low-level Windows application running on Unix that our development team would SSH into as recently as 8 or 9 years ago, definitely since I've been at Synergex. It's since been updated to use Toolkit and run on Windows. Suffice to say, the codebase has some history and a number of maintainers. The only advanced preparation that the source has received for migration is cleaning out all the built objects and libraries and making sure I have a schema version of my repository, and checking the whole lot of it into a Git repository on Visual Studio Team Services for easy portability. There's also an empty solution just to make sure my projects get the right directory structure off the bat. Now, to know exactly what I'm supposed to do for this demo, there's a handy list of work items over on Visual Studio Team Services, and if I look here, it seems the first item is a build failure. If I dig into this, I'll see an industrious little unit test failed and resulted in a work item getting created automatically. In order to fix this first work item, we're going to have to put together the complete Visual Studio projects and ensure that everything is building to the right place. So let's dig in. So let's get into Visual Studio and open up that blank solution that I mentioned so that we know everything is going to the right spot. So here we go. This is the Tracker solution in all of its glory with 0 projects ready. The first step for bringing Tracker into Visual Studio should probably be getting our repository set up. So let's go ahead and add a repository project. And this comes with a sample schema. We're not going to need that because we have our own. First thing that we're going to need is to set up an environment variable for where our repository lives. And I just know that is the solution dir up a level RPS. And then let's get our schema file. And let's make sure that we have this set up. So I'm going to set the output path for the repository so when it's built, it goes to the right place where the other projects are going to consume it. And I could, of course, name this something else if I wanted to, or give it a different default extension, but I'm going to leave that as is because that's the way we're using it. If I go ahead and build that, I got one succeeded, and I could even go over here and double check to make sure that I now have an RPS main and RPS text with current date. So let's go to something more interesting. In order to know exactly what makes up Tracker, the best choice is for us to look at the existing make file that's used to build the product. So I happen to have a copy of it since I have the complete source tree. And if we dig through the make file, we'll find out that the track.dbr itself has a dependency on track.dbo and track.elb. Track.dbo being the one source file that makes up this mainline, and track.elb being the library of routines. I happen to also know that we're going to need to make xftrack.elb for runtime, so we'll set that up too. But let's take a look at what makes up xftrack and track.elb. Track.elb is track.olb. Track.olb is the track.elb sources as DBOs all linked together. I think we're going to skip the OLB step because we really don't need it. So let's just go straight to an ELB. So for track.elb, I can see that these are my sources. And let's just go ahead and get those added to a project. Guess it helps if we have a project first. We should do a few minor setup steps before we add sources, like make sure we have the right name. So I know this is turning out as track.elb. Let's set that up. We can tell it's an executable library. And if we take a look in here, we also know that it needs to build to version 951. So this whole QRT compat line is to make sure that this product will run on the oldest version in-house. I think there's 951 on a server somewhere. So Tracker's supposed to work everywhere, so let's make sure we do that correctly. It's correct. We haven't set up that environment variable yet, so let's do that. And this is specifying where we're going to build the project out to. Okay, everything looks good there. Let's add sources. We don't need this default routine. And I'm going to cheat just a little bit because I have those sources in a friendlier format. Make sure we're coming from the right directory. All that's from tracker source. And the rest of them still. And so now I think I have all the sources I need in order to build track.elb. Let's go ahead and give it a try. Oh, we seem to have some errors. 581 errors. That's really scary. I don't want to deal with 581 errors because I just want my project to build in Visual Studio. Well, if we look at them, it turns out they're not all that bad. They are mostly all straightforward, and I think we can fix them pretty quick. So the first one, it's not finding my RPS infill. I should probably reference my repository just to start. Oh, we're already down to 247 errors. Oh, well, that was easy. Let's see if we can fix these other ones. Cannot open trk source : Well, we haven't defined a trk source, so let's make sure that gets set up. And I'm pathing these off my solution dir so it's more portable, right? Because now I can check out my project anywhere and get the right paths. Let's see what happens now. I'm down to 20 errors. That's seeming pretty good. This one doesn't look quite the same. IA rec : I think we could fix much the same way. What about now? I'm down to 4 errors. Perfect. So track.inc, what is up with this guy? Why can't we find this? Oh, because I haven't specified a logical, it's going to look in whatever directory that we're building in. Well, that's bad. I don't really want to change any of the source because I don't want to have to make explanations for these check-ins, anything like that, and I just want to make Visual Studio work. I think the correct answer here is actually to change this to trk source : but we're not going to touch it. Instead, we're going to tell the project what directory to use when it's building and see if we can solve the error that way. Down to 1. Okay. Symbol already uniquely defined. Update queries. Oh. At this point, I would copy this error message and send it to the development team so that they can fix it. Support, get ready for this one. Okay, so update queries screen. It said that it's already uniquely defined. Does that mean that there's more than, yeah, there's more than one of these? I have 2 declarations of it. How did this ever work? I don't know. Well, let's take a look. How different are they? This one includes track.inc. It has some logic, has some commented out stuff. Okay. What about this other definition? It includes track.inc, and even has the commented out bits. Well, this one's called synutils. I'm going to assume that this guy gets used in more than one source area, and this tr routines thing is specific to Tracker. I'm going to go ahead and comment the one out here so that we no longer have a duplicate since they look identical. Oh, we've got a different error. Did I ever set up the compile flags for this project? I should make sure I've got them right, shouldn't I? So if we look back into the make file, we can see that DBL. This is how it compiles a DBL file into a DBO. It does the QRNT compat, and it uses XT. I don't think that's the default, so let's take a look. I have T, but I don't have X. Let's go ahead and turn on X. Oh, I still have errors. These are link errors. These are different. We haven't referenced any of the synergy ELBs at this point. So let's see. L class, init, XML doc, uclose. I see synxml in here and tklib. Oh, let's just take care of that. So if we come over to the Solution Explorer and go to References, we can go to the Synergy tab to see a list of the ELBs in the default location. So dbldir, rpslib, wnd. So let's go ahead and get our tklib and our synxml and see how that does. Oh, closer. We need ddlib too. Let's do that. And build 1 succeeded. Is that right? Let's take a look in our exe directory. Hey, we have a track.elb. Well, that wasn't so bad. Let's go ahead and do the xf track one then. Let's see if we can get that out of the way. So add new project, xf track elb, and let's go ahead and do some of the things that we already figured out last time. So go to the properties. xf track is the name of the output, right? Take a look at that make file. xf track. Don't know if we need to do the working directory here. Make sure we've got the 951 set. Xedir is the right build location. And let's use the same compile flag because that's all common. our environment variables here have carried over because we're setting them up in common properties. That means they carry across all projects in the solution that have this feature turned on. So we don't have to set any of that stuff again. Let's just go ahead and add sources. From the right location would help. These are still coming from TRK source. And let's add our references. We said XML, ddlib, tklib, and we need to add the repository project. Is that build? Oh, we have to do the working directory. We don't have to. Like I said, we could just fix the include to do the right thing, but I think it would be better if we just, didn't change source. What is this? RD query, FD query. Well, do those actually get called somewhere? Can we find that? FD query. What is this all about? I could go dig through the sources, or I could know that this is actually a missing source file. So when I look at the make file, there's no reference of this missing source in terms of an xftrack dependency, though I happen to know that xftrack is missing ioquery.dbl, which will have our missing fd query and rd query methods. So this just goes to show that even the existing build system might not have everything right. So just make sure you're giving a hard look at the errors when you get them. Let's go ahead and build this. Hey, xftrack built. And we have the ALB. Well, what about the actual tracker application itself? So what did we say it required? It requires the DBO and the ELB, and it has a dependency on tklib, axlib, and ddlib. Let's do that. New project again. This time we're going to make a traditional application DBR project. This guy is called tracker. Set some properties on it. If we want to be consistent, it should be track.dbr. That's fine. Go back to compile, fix our one flag that's common, and then make sure that we're targeting the right runtime version. Xeder is good. Remove this nice placeholder program and add our one source file. Track.dbl. And then let's add some references. So this guy needs the repository, probably, and track ELB is the main library that it's going to depend on. And then let's add axlib, what'd that make file say? ddlib and tklib. Try to build that. Oh, track.inc is biting us again. Maybe we should have just fixed the source, but pressure's on to not make source changes, so let's just fix the project. Well, that built. Does that mean we have a DBR? We have a DBR now too. Oh, that's tiny. Well, maybe it runs? We're gonna set it as the startup project and give it a go. Hey, we got tracker. Wonder if my login credentials work. It seems to be fully, hey, we even have data. It must have the paths correct somewhere. This stuff is current. Maybe it's internal. Maybe I shouldn't be showing this, but it demonstrates that this is actually the real tracker product running on real data, and all we've done is build up some projects around the actual source files. So not bad for a start of work. So what was our original task here? We wanted to fix a build failure. Well, we have a successful build. Let's make sure it builds in release too, because I'm sure that's what our build server is going to do. Looks good. Okay, so we have our solution building here in release x86. I'm pretty sure that's what we're going to build up on Visual Studio Team Services once we check this in. So let's make sure that we've closed out, it's saved, we're good to go, and let's see what the damage is down here. We got a handful of new files. We probably don't want to check in the RPS main and ISO. We'll just let it all go. So we're going to go ahead and add. If I were being nicer to my build maintainer, I would not be checking in these binaries, but I'm just going to let them go for the sake of demo. So we're going to commit shim conference demo and push it. So you can see this actually has a URL for our team services instance on it. We have just pushed it upstream to the actual team services for this. So after we check it in, continuous integration can pull it on a remote system and build it. But I think there's some problems with the way that's configured right now, so we're not even going to worry about it. We have it working here locally. That's good enough. So what other tasks are in here? What kind of time do we have? Okay, so we fixed this guy. Let's go ahead and mark it to resolved. Update tracker to auto login as last user. That seems like a useful feature, but I'm not really a Synergy programmer, so let's skip that. We do want to demo working in Visual Studio a bit, so maybe this one's more my style. Change default font size to 15. That seems like it's right up my alley. So if I come back over to Tracker, we're going to figure out where it is that this font size gets set and see if we can change the default. I'm pretty sure if we run Tracker, we can see that it has options for font size per user. So that probably gets stored somewhere. Change font. We can set our font preference, our font size, sizing character. I'm not going to change any of that because I don't want it to set up any preferences for my user. So let's see if we can figure out where that happens. Change font was the menu entry. Or was it? Font? Font type. Oh, that's in the repository. Point size, that's an admin start. Font. How about this guy? Hey, xcall wind font, get font current, face name, point size, sizing char. So this seems pretty promising, and it looks like it gets some information. Choose font. What is this method called? It is subroutine send utils. I don't see any default in here though, but maybe if we follow this trail. Wind font. Tracker font global. Set font. If not wind font global. Hey, this looks like a default right here. Let's give that a try. See if our 15 point size works. I'm just gonna press start and get an error, send that to support. It's all good. And see it, whoa, that already looks a lot different. So does that carry through? Yeah. So we've done it. We have successfully changed the default font size using the tools. I think that's cause for celebration, but we'll let my manager decide whether or not that's sufficiently good work. So what we've done today, we have taken an existing product written in Synergy, who knows how many years ago. It's been maintained by a number of different developers across multiple platforms, and we very quickly brought it into Visual Studio as usable projects. We brought all the source in. We brought all of the build requirements out of the original makefile, and we made sure it builds to the similar or same directory structure that it already used, because this guy's expecting exe track. We've made sure it's in the right place. So even if we only did part of the product right now, other things that are expecting those files to be in those places can still use them. And we also did this by bringing a repository into Visual Studio as well, so that I don't have to manage the RPS infill and tfill myself. I can actually just put my schema file into a repository project, let it build, and let the project reference propagate out my infill and tfill. It's really not that hard a process. I think that most of you can do this with your existing source base. Just make sure you look at the details of what you're building. Make sure you understand the compile flags and options that are being used, and that you set them up to do the same thing in Visual Studio. We give you a nice UI here to handle setting all of those values. And of course, if you have any other options, we give you a spot for that. And if you have questions, if none of this makes sense or you can't find the option you're referring to, just send an email to support. We'll be happy to find out the right answer and make sure that your project is set up correctly. Who has the first question?
Is the prototyping something that's just, when you move it to Visual Studio, you're going to get prototyping, and that's required for the build?
So the strong prototyping is required for building in Visual Studio, and it is what drives our entire IntelliSense system. So it would be possible to edit code in Visual Studio without using our build system, but the prototyping is required in order to actually go through and have the full experience.
Okay.
If I make a change just to one structure, will that cause only dependencies that require that structure to rebuild, or any project that has a dependency on the repository to rebuild?
So right now, the checking against the repository is done on timestamp. Like we want to do with ELBs, we would love to be able to do more specific dependency checking in the future, but right now it is just going to be if the repository itself has changed in any capacity, all of the dependencies will build.
For somebody who might have, like, let's say, 2,000 schema files that make up their repository, it's still best to do that as an external item?
Yeah, definitely right now you're going to want to continue running your external build because you already understand the order that those schemas have to be loaded. And we are working on the RPS util changes for us to be able to do it in Visual Studio without having to know the order, so that it can just happen automatically.
Okay, thanks everyone.